Welcome to Systemed Mastery, 13 lessons to take you from PID-1 mystery to senior fluency. Here's the reality in 2026. Every major Linux distro, from Ubuntu to R Shell to Arch, boots systemed as PID-1. It's the most consequential piece of user space since the kernel itself, and yet most engineers only ever learn it through Stack Overflow archaeology. This series fixes that. Lesson 0 is the foundation, the Init story, what systemed actually gives you, the controversy worth taking seriously, and the roadmap ahead. To understand why systemed exists, you have to feel the pain it was born from. For nearly 30 years, Linux booted by running shell scripts in etc. init d, one after another, in alphabetical order. 4 problems made that model untenable. Boots took minutes because nothing ran in parallel, crashed daemons just stayed dead because nothing was watching. Dependencies were faked with file name prefixes like S20 network, and every service scattered its logs into its own format in its own directory. Slow, blind, racy, and unsearchable, that's the world systemed inherited. So let's put those two worlds side by side, same hardware, same services. On the left, sysvinit in 2010. Network at 5 seconds, syslog waits until 12, SSHD at 18, Apache at 25, Postgres crawls in at 38, and you finally get a login prompt around 55 seconds. On the right, systemed reads its target tree, fans out network and syslog in parallel at 1 second, brings up SSHD, Apache, and Postgres together by 3, and hits the login prompt at 5. 5 to 10 times faster, and that speed is just the surface effect of being structured and supervised. And that speed is one of 4 superpower system hands you on day 1. First, a single init for the whole system: boot, services, sockets, devices, mounts, timers, swaps, all driven by one tool, systemctl, replacing the old zoo of init.d, rcd, cron, xinit, and monit. Second, C-group-based resource control. CPU quota equals 50%, one line in the unit file, and Apache can never again eat all your RAM. Third, journaled, structured queryable logs where grep and awk pipelines collapse into a single journal-style flag. And fourth, that dependency-driven parallel boot we just watched. Declare what you need, systemed computes the graph. 4 capabilities, 1 manager. That's why every distro caved. Before we go deeper into the theory, let's ground ourselves in the muscle memory. These 5 commands cover roughly 80% of your daily systemed interaction. Status to check if a service is alive. Start, stop, restart for lifecycle. Enable and disable to control boot behavior. Reload to reread config without downtime. And journal ctl to tail structured logs. Master these 5, and you can already manage a fleet. The remaining lessons unpack the why, and the advanced 20% that separates operators from architects. Now, let's be honest. Systemed is the most criticized infrastructure project in modern Linux history, and the critics aren't simply wrong. 3 concerns come up again and again. First, scope creep. What started as Init now ships journaled, networked, resolved, time-synced, log-inned, homed, even a bootloader. Second, the binary journal format. You can't just grep it, and corruption can cost you everything. Third, centralization. One Red Hat-influenced project controlling critical infrastructure, which is exactly why Dargslan, Alpine, and Void exist. Each concern has a reasonable counter, but knowing the debate makes you a better engineer than pretending it doesn't exist. So where does that debate actually leave us in practice? Roughly 95% of the Linux jobs you'll touch run systemed. Every major server distro, every mainstream cloud image, most container bases. The other 5% is worth knowing by name. Alpine and BusyBox in containers, OpenWRT on routers, Dargslan and Void for the philosophical holdouts, the BSDs still on RC8, and of course, Mac OS and Windows with their own service managers. Print this matrix. When a job description lands, you'll know in seconds which column you're in. Knowing you're in the system column is one thing. Knowing why to invest deeply is another. 3 reasons. 1. It's the universal operations layer. SSH into any production box in 2026, and System CTL, Journal CTL, and System D-Analyze are your first conversation. 2. Modern infra is built on systemed primitives, C groups, namespaces, dynamic users. Docker and Kubernetes didn't invent that isolation, they inherited it. 3. It's the line between scripting and systems engineering. Juniors write cron jobs and hope. Seniors declare dependencies and supervise. Systemed is the bridge. So here's the road. 12 lessons, 4 stages. Foundations cover lessons 1 through 4. PID 1, unit file anatomy, service types, and targets. Operations, lessons 5 through 7, is where you start writing services, querying the journal, and replacing cron with timers. Advanced takes you into sandboxing, C groups, and socket activation. Then lesson 11 is the honest one, when not to reach for systemed. And 12 is your graduation, a decision flowchart for production. Print this page. You'll come back to it. Before lesson 1 even starts, do these 3 drills. 10 minutes. Read your boot logs with Journal CTL and System to Analyze Blame. Find out what your machine actually did this morning. 20 minutes. List every running service and pick 3 strangers to interrogate with System Subtle Status and CAT. 30 minutes. Pick a service you rely on, read its unit file, and write down every line that confuses you. By the end, you've touched systemed more deliberately than most engineers ever do, and you'll have real questions waiting for lessons 2 through 8 to answer. While you're doing those drills, expect to trip on these 5. Editing the vendor unit in lib instead of running system CTL edit, gone on next apt update. Forgetting daemon reload, so your restart reruns the old config. Tailing var log for a service that now writes to journaled. Confusing start with enable, then wondering why nothing came back after reboot, and kill 9 on a PID that system just respawns, leaving the C group in tatters. Hit 3 of these in week 1 and you're normal. Knowing them now saves you the debugging. And that's lesson 00. You've got the Init story, the 4 superpowers, the 5 commands you'll actually type, and a map of where the next 12 lessons are taking you. Next up, we go under the hood. Lesson 01 is PID1, the dependency tree, and the target system. How systemed actually boots a Linux box, start to finish. Foundations, stage 1 of 4. See you there.